Hello there. Welcome to Chapter 5, Section 9. We're talking about similar figures here. If you've kept up with those proportions, and many of you have, this should be, I think, relatively painless for you, and I think we can get through it pretty quick. Hopefully, uh, probably 1.5 videos, something like that, as we work through it. Please mark your questions and bring them to class for tomorrow. Similar figures. Okay, let's begin with the key concept. I am looking right here. The key concept of, well, what is a similar figure? Hopefully you've run into these before. Simply put, a similar figure, or two similar figures, they have the same shape, but they're not necessarily the same size. So they're not necessarily the same size, but they have the same shape. Okay. Um, if they are similar, here's one thing that we know. If you take a look at the picture of the model right here, okay, if you take a look at these two figures and they're telling you that they're similar, they look a lot alike, but this one is a little bit smaller than the one on the right. But one thing, notice this, the corresponding angles are congruent. Now, congruent is a fancy word for equal. It is a math word you should know. So look at it like this. Even though this is a smaller triangle on the left, notice this angle A is equal to angle X. And they're actually telling, that's what they're trying to tell you right here. Okay, now this fancy symbol here, this wavy sign, equal, that means congruent. That's a geometry term, meaning that the two angles are the exact equal size. And angle B, if I were to ask you what is angle B congruent to, you would say angle Y, and angle C, I'm going to do 3 lines there, matches up angle Z. So those are congruent. Okay, but what are not congruent are the lengths of, say, this side and its matching side, XY. Okay, those aren't equal, but they are proportional. So we could actually set up a proportion, which is what they're trying to tell you right here. And they're telling you this right here. Okay, the corresponding sides are proportional. Okay, and opposite corresponding angles are equal. Okay, so what they're saying here is say you have AB over its matching side XY. It's saying that those are proportional. Therefore, if you took, say you took BC, you could put that over YZ. Okay. And then you could, so if you knew 2 of those or 3 of those sides, you could find the unknown, which is what you're going to be doing here using a proportion by crisscrossing and dividing. It's very easy if you've kept up with class. And they're basically telling you the same idea right here. Okay. If you look at these two figures, if I said, well, hey, what corresponds with A? Hopefully you would see that E does right here. And that's what they're saying right here, that those corresponding angles are equal. And that's what all of this part says here. Now, let's say I'll maybe use this one over here so it won't get quite so messy. If I said, what does CD correspond to? Hopefully you would say GH. And that's what they're saying right here. So notice how they took that little arrow there and they're telling you that those two correspond to one another. Even though the corresponding sides are not equal, corresponding angles are equal. So we can use all of that to find unknown values, which is what you're going to do on the back of that paper. If you want to flip that over, you should see this picture right here, and I'll show you how this works, and hopefully you'll just be able to jump right into things and solve these correctly. Let's take a look at the first one here. All right, so it says the figures are similar. Okay, so you have to know that first. Okay, so they are similar, so we know that the lengths of the sides are proportional. So sides are proportional. That's what the opposite side of this paper told us. Sides are proportional. Okay, so let's write this right here. If I took, let's start here with FD, because that's my unknown. So ultimately, you're trying to find X. All right, you're trying to find the value of X. All right, it's right here. It's this side. So I know that FD, now I put a little line there because that means a line segment. FD corresponds, that arrow, this arrow right here means corresponds. Think of corresponding to as the matching side from the other figure. FD corresponds with RP. Okay, so since those correspond, I'm going to put the length of FD, which is X, over RP, which is 5. All right, so I put FD here. I put RP on top. Okay, now that we're going to set that equal to another set of corresponding angles. And maybe I'll change colors here. If you have a highlighter, you can do that. I know that DE, right, DE. Now notice I put that one first because I did FD first. So I used this first. You have to use the same shape first. Whatever you use first and the first time, you have to use first and the second time. So DE corresponds to PQ. And you know what? I should have lines over those. So since DE corresponds to PQ, I'm going to take DE, which is 8. I'm going to put it right here. 8 over, and that's DE. I'm going to put that over the value of PQ, which is 12 up here. All right, so if you can see where I got all those numbers, I took X over 5, and then I put 8 over 12. Since I put X on the top from this figure, I have to put this 8 on top in this from this figure as well. All right, now at this point, you're just going to solve, because the question is asking you to find the value of that X. So solve proportion. All right, well, I'm going to crisscross. Remember the lesson we learned, 12 times X is equal to 8 times 5, which is 40. We're going to divide that by 12. Check that on your calculator, and what you should get is 3.3 repeating. So we'll just write it 3.3 with a bar over this 3.3 repeating centimeters right there. And that's it. It's that simple. So again, if you've kept up with proportions, this is pretty simple. It's very much like a scale model figure that we've been working on in class. Let's take a look at number 2. Now this one is an interesting one because you have to actually take this this trapezoid. I'm going to trace over it quickly. It's not going to be perfect, but try to make the point for you and see if I can. I'm not sure if this will work or not, but I'm going to see if I can do a little trick with my smart notebook. You have to actually imagine this whole figure is flipped to see the corresponding sides. So you see how it's kind of upside down in one of the figures. So you have to imagine this whole thing is flipped over upside down, and then we can identify the corresponding sides, which this corresponds with this. Okay, so OP corresponds with KL. All right, so I'm going to write down here the length of OP is X, the length of KL is 7, and that's equal to, I'm going to do the other corresponding sides. Now you can pick either one here because you notice you have 27 corresponding with 9 and you have 36 corresponding with 12. So you can pick either one of those to solve this question. I'm going to pick 36 and 12. All right, so I'm going to say that ON corresponds, I should have a line over that, ON corresponds with KJ. I think I said KL, I meant it's actually a KJ up there. Okay, so I have ON is 36 right here. All right, there's ON, it's 36, over KL is 12. There's your proportion. Now you just have to crisscross and multiply. If you do that, you get 12 times X is 12X. 7 times 36, punch that in your calculator and you'll get 252. You divide that by 12. Divide that by 12. You get X. You work that out. X is equal to 21 inches. And there you have it. Okay, so it's really pretty simple. I do need to do one more problem, but I need to start a new video to do that. It should be really short for you. It's an easy one, but I want you to see an application of it. So I'm going to stop this one and start another one, and you'll be done in a moment.